Good morning. I am Mr. S. You are joining me for this interesting video here where we will look at two concentration word problems. Just because we're using the word concentration, it does not indicate that this is a chemistry problem by any means. Concentration are legitimate algebra word problems and you can and will see them. When you're handling problems of these types, there's a bit of intuitive knowledge that you should know. As I read this question, I'll talk about what that intuitive knowledge is. Intuitive knowledge basically is that information that you must know prior to being able to solve these type of questions. It's the information that you are expected to know over the course of your life, the information that you will have gained and acquired from your surroundings. The question is this: a car radiator has a capacity of 7 gallons. It is 15% concentrated. How much of that must be removed and then replaced with pure engine coolant to increase the concentration to 21%? So what is some of this information that we should already know? One is this: we should know what a car radiator is. It's a specific equipment in your car engine which helps to maintain the temperature of that engine during function. Another and perhaps the most important aspect is this capacity in the 7 gallons. While that 7 gallons might be a hypothetical figure, but all radiators have a fixed capacity. They must always be filled up to that full capacity. So we're talking about here in terms of finite volumes, and the finite volume we have is 7 gallons. And when we're looking at a problem as this, you must have your radiator filled up to that capacity in all instances. So let's handle this problem, and the best tip I can give you is to formulate your algebraic expression as you read this question. So let's start. A car radiator has a 7-gallon capacity and it is 15% concentrated. So we know we have 7 gallons and it's 15%. We can convert that into decimals. How much of that must be removed and replaced with pure coolant? So how much means how much volume must we remove of that original solution, which was 15% concentrated with regards to the engine coolant, and then we must replace with pure coolant. So what are we removing? We must add back the same volume so that we maintain this fixed capacity, as you know. And pure coolant over here is a critical item to know. If you're talking here about concentration with regards to coolants, then pure coolant must be 100% with regards to concentration, and 100% would just be 1, because 100 divided by 100 is a 1. To increase the concentration to 21%, you know the volume is still fixed. C7 minus x plus x will still give you 7 at 21%. Now it's just a matter of simple algebra to solve this, and we can. We'll have a 1.05 over here minus 0.15x plus x is equal to 1.47. You just have to solve for this x. This 1x over here is just an x. 0.85x is equal to 0.42, and then x is equal to, you just divide the two numbers. We get a 0.494 gallons. What does this answer indicate? That you're going to remove 0.494. You could round this up to like a 0.5 or a half. We're going to remove half a gallon of that existing volume from that radiator, which was 15% concentrated, and then we'll put in exactly half gallon of pure coolant, which is 100% concentrated, and it will increase the 15% to 21%, and the question will have been solved. And now you can see some of that intuitive knowledge that you should have known. Most importantly, what is a radiator, and that all radiators must always be filled up to full capacity for that car engine to function properly. The next question is built off the same question with a few tweaks in the wordings, and we'll examine that next. The question is this: a car radiator has a capacity of 7 gallons. It is 25% concentrated. How much solution must be removed and replaced with pure water to decrease the concentration to 18%? Now in this scenario, the car radiator is overly concentrated in terms of the coolant, so you got to add water. That means you got to dilute it down to 18%. The most important part over here is now with regards to engine coolant, what's the concentration of pure water? Well, pure water will be nothing other than water, therefore it must be 0% with regards to the coolant. So how can we do this algebraically? Write it out as you read it. We have 7 gallons of 25% existing engine coolant in your radiator. How much solution must be removed? How much of this existing 25% are you removing and now replacing with the same volume out of pure water? But pure water is 0% in terms of coolant, so you're putting a 0 over here to decrease the concentration to 18%. You should still end up with the same volume, 7. You're removing the same amount, you're adding the same amount to keep the volume fixed. and it must be at the end 18%, because in this scenario the coolant was too concentrated and therefore it was not functioning very well. So we just have to calculate this. We have a 1.75 over here minus 0.25x, this zeroes out, is equal to 1.26. All you gotta do is solve for x. Minus 0.25x is equal to minus 0.49, and x is equal to 1.96 gallons, but gallons of pure water. We must remove 1.96 gallons from the original radiator. The capacity will go down, but then you replace that volume back with 1.96 gallons of pure water, and we'll bring it back up to 7 gallons. But in that process, by adding pure water, we will have decreased the concentration from 25% to the ideal 18%, and then your question would be solved. So the answer is this. You're going to remove 1.96 of the original and you'll add 1.96 gallons of pure water to come to the desired concentration. And that's it for this video. Stay tuned. Thank you for watching. Have a nice day.